Hello everyone, my name is Padina Farokhian and I'm a master's degree student at Khaja Nasser's University in Iran. This project is being conducted under the supervision of Dr. Khan Kalantari. So today we're going to talk about AI-powered UAVs for plant disease detection. So, first of all, why we even use UAVs in agriculture and also integrating artificial intelligence with it. The problem is that today, in today's world, some outdated methods of farming can't be applied to agriculture anymore. And for example, if we want to use pesticides, there's a high percentage of many crops dying out, so that the yield process will be decreased. And although there are these problems mentioned here, there is a solution for it. So the solution is using deep learning and artificial intelligence methods, so that we can actually use it in cases such as crop monitoring and pest and disease detection, yield prediction, and weed detection. There's a roadmap here being presented for you, and there are generally 4 steps. The first step is image acquisition. So here we have RGB cameras and multispectral cameras, hyperspectral cameras, and thermal infrared cameras, which are the 4 mainly used cameras in this field. So for the step 2, we have image preprocessing, which actually we use it for making the data ready so that we can give it to our data, so that our model can give it to our model, so our model can be trained and then be validated on that data. We have 2 subsets of step 3. The first one is actually pointing out the machine learning methods, while the other one is showing us the deep learning methods. So there are some differences. You can see that the deep learning process is much more autonomous, rather compared to the actually machine learning method. But at the end, in step 4, we can see that we will reach to a classification where we can actually assess the healthiness of crops. And this is another roadmap that I have put here for you guys to actually see, and but it is actually detailed, so we won't go through it. You can pause the video and actually be more informed of what it's saying, but overall it's actually pointing out the stages and how the data is being acquired, actually gathered, and at the end we have the models and methods being used for actually training our model. So moving on to the next part, how do we get the data from the fields and the crops and these stuffs? We use cameras on drones, so we call it UAV imagery. There are 3 different, actually there were 4 that I mentioned before, but here in this photo we have 3 different cameras, which you can consider as sensors, remote sensing actually objects. So the first one is RGB, which is the usual and actually mostly used one among all these three, and I will mention why it is like that. So the RGB images actually capture the growth status of crops, and on the other hand, thermal imaging sensors capture the temperature of our plants, so it can identify the water stress of it. And the more advanced one, which is called multispectral imaging, is actually cameras being used for gathering more information of the plant or the crop on the field, so it can actually analyze and give us more detailed results. And this is another picture. This is actually the subset number A is an RGB image, and number B, C, and D are the same image while being processed in a different way, but they're all being captured by RGB cameras. And we can actually see four different types of cameras here, which can capture different variations of wavelengths. And at the end of this page, we have two actually groups of capturing data. This is a low altitude UAVs, and another one which is a high altitude. This is another comprehensive table that I'm not gonna go through it deeply, but for example, the first one, RGB cameras, we can see that they are one of their advantages is that they're lightweighted and inexpensive. That's why they're being widely used. But their disadvantage is that they can be vulnerable to environmental factors. And these are the use cases that we see here. I mentioned before that I will talk about datasets. This is a table representing popular datasets. Plant Village is the most popular one, as I assume, because it is published on Kaggle, if I'm not wrong, and it has taken images from a low altitude from plants, and some of these datasets are available, and I've checked it out, but some are not available, or the site is out of reach. So, but you can check it out yourself and see if you can access these data or not. So, moving on to the methods part. There are generally two groups of methods being used when it comes to smart agriculture. The first one is machine learning, and the second one, as we mentioned, is deep learning methods. There are some comparisons being made in this table. For example, for machine learning, our training time is faster, while in deep learning it is more time consuming because of the neural networks being used and the neurons, which will have some calculation costs for us. While for feature extraction, we can actually have the upper hand when it comes to deep learning methods, because the pre-processing method or the augmentation or even labeling, these kind of stuffs can be done automatically, while here it is more manually. And you can see